All right, so for this second video in section C, I just want to go over a few examples with you guys. So this way you can see a little bit more clear about how it'll be presented in your book. I did think though that video was just different, could maybe change things up a little bit, add a little bit to the videos that you guys watch, so it's not just the same thing over and over again. And I thought it did a good job at explaining the topics. But now I just want to go through a couple of the examples. So for this one here, it says, consider set S, and it tells us that set S is equal to 2, 4, 6, and 7. And it's within the universal set where U is a set of all x's such that, let me just highlight this as we're reading it, that the set U is equal to universe is equal to the set of all x's such that x is less than or equal to 10, and x can only be positive integers. All right, so when we define our universal set, there is nothing else that our numbers can be except for these here, right? And they can only be the positive integers. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, that's it, nothing else. So it says draw a Venn diagram S. So we're first going to start, and there's our universe. And within our universe, we have our set S. So we can go ahead and we can label this set S. We're just going to label it out here. All right, and then within that set, we're going to label everything that's in that set. So we have two, hold on, I want to do that in a different color. Don't know why it didn't register. All right, so we have 2, we have 4, we have 6, and we have 7. All right, so those are all of the elements that are within that set S. So here, the first thing is draw a Venn diagram to show S. Now we want to list all of the elements that are in set of our complement of S. So our complement of S is equal to all of the elements that are in our universe but not in our set S. So here, our elements in our universe are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. All right, and within this universe, set S contains 2, 4, 6, and 7. So that means our complement of S are the elements 1, 3, 5, 8, 9, and 10. So then to finish this drawing of our Venn diagram, we can go ahead and list 1, 3, 5, 8, 9, and 10. We can list these here to let the readers know the elements that are contained within our complement of S, or within the universe that are not within our set S. So now it says here they want us to find a couple answers. So for I, we want to find the number of elements that are in set S. So we're just counting the number of them. So there's 1, 2, 3, 4. So there's 4 elements within that set S. We want to know the number of elements within the complement of set S. So here we would have 1, 2, 3, 4, 5, 6. Or we know that we have 10 elements in our universe. There's 4 in our set S, so we could have did 10 minus 4, and that would have given us 6 as well. Either way, for this one, it really wouldn't matter either way because there's not that many you have to count. But let's say the universe had 100, it would be a lot easier for you to subtract them. And then the last one, the number of elements in our universe, it says all integers from 1 to 10, so that means the number of elements in our universe is equal to 10. All right, that's it for this problem. There's one more that we're going to do, and then that's it for this video. All right, so for this one, they give us the universe is all integers between 0 and 12, and it tells us what A and B are equal to. It just wants us to draw a Venn diagram with this. So we're going to first start off by drawing our universe, and then we're going to draw set A. Let's label this A. And now before we draw this, we got to look and see, do they share any elements? Because if they don't, then they won't overlap or intersect. They will just be separate. Well, this one has 3, this one has 3, so I know that they at least share that one. So I'm going to go ahead and draw my set B with the overlap, so that way, because we know that they do have some intersection. So now all we're going to do here is we're just going to go ahead and we're going to list every single element that's in A. Now, any one, I'm going to highlight the ones that are in both. So 3 and 7 are the only ones in both. So that means 2, 5, and 11 will go here. For B, we will do 1, 6, and 8. And then in here, we will write 3 and 7. And now that means what's left over is 0 will be in our universe, but not in either set A or B. 1, 2, 3, 4 is not in either set A or B. 5, 6, 7, 8, 9, and 10, and 12. All right, so this is what they wanted you to do for this one. So this is kind of some of the questions that you might see within your book. So I thought that these two examples could just supplement what the video that you watched before. All right, and that's it for this video.